Welcome back to RSM 701. This week we're working on non-parametric statistics. Parametric statistics require that your data be normally distributed. So the tests we've been focusing on so far, like t-tests, ANOVA, and regression, require a normal distribution. But what do you do when you don't have a normal distribution? Say, for example, when you have categorical data. Well, that's where non-parametric statistics come in handy. This type of test is not as sensitive, but it's also not as fussy. So you may miss something significant, so we only use it when you can't do a parametric test. Chi-square tests are used to determine whether observed frequencies differ from expectation, and we use it with two categorical variables. So today we're going to use a categorical variable of sex, that is males and females, and promotion. So again, categorical, yes or no, people who were promoted or were not promoted. And we're going to do a chi-square test of independence. There's also a chi-square goodness of fit test, but that's not the focus of our analysis today. So how would we phrase this question? Again, I said we have two categorical variables, and what we're really interested in is there a difference between the number of males and the number of females who were promoted? And our variables are gender and promotion. So what we're going to do is go to Analyze, Descriptive Statistics, and then we're going to go down to Crosstabs, and we're going to put sex or gender in the row box and promotion in the columns box. It really doesn't matter which one is in which. If you have a variable with a lot of categories, you'd probably want to put it in the row box just so that it looks better. Then we're going to go ahead and click Statistics, and we're going to do the chi-square test, and we want to know the effect size, so we click on V and Kramer's V as well. And then we're going to click on cells. It gives us the observed counts automatically, but we're also going to click on expected because, again, the chi-square test is looking at whether there is a difference between the observed frequencies and what we would expect. And then if you'd like, you can also click this box, Display Clustered Bar Charts, because it gives you a nice visual of your results. And then click OK. So when we get the results of our chi-square tests, the first thing we want to do is look at whether the assumptions have been violated of minimum cell frequency. So you look at this footnote here, and it says 0 cells have an expected count less than 5. So that's great. That means we can move on. The requirement here is that at least 80% should have at least 5 or more in each cell. So in this case, this is fine, and we can move on. We're also going to go look at the difference between the observed and the expected. So here, because we had 25 participants in each category, you can see that in the total boxes, we would expect to have 12.5 in each of our 2x2 boxes. And you can see that that's pretty close. There were 12 females who were not promoted, and 13 males who were not promoted, 13 females who were promoted, 12 males who were not promoted. So pretty close to what you would expect if they were just exactly equal. And if we look at the chi-square test, you can see that the value is 0.08. The significance is 0.77. So it is not significant. And when we write this up, we would write it as researchers were interested in determining whether or not there was a gender difference in being promoted. A chi-square analysis was conducted, which returned chi-squares. The degrees of freedom was 1. The value is 0.08. So we're going to write that right after the equal sign. And the p-value is 0.77. So that suggests that there is not a significant relationship between these two variables. In fact, looking at the data, we can see that 12 out of 25 males and 13 out of 25 females were promoted. So there really isn't a difference between, and that's what our chi-square test is telling us. If there was a significant difference, we would want to look at these effect size. But as you can see, the effect size is negative 0.04 for this case where it's dichotomous variables, and that's not significant. And you can also see that in the bar chart that really the males and females were about equally likely to be promoted. Okay, so good luck with your chi-square analysis.